What's up, fellow weirdos? How you doing? Madrigo here, and today I have a special video. This is the first video I have on the subject how to build your own embedded system / electronics laboratory. I'm gonna start by the first and probably the cheapest instrument you can get, a signal generator. So if you're just like me, you like saving money, right? Money is really an expensive thing, and the cheapest way to get your tools is by buying on the forbidden land of the forbidden capitalism, China. So if you're like me, you go to AliExpress and see if you can get a cheap module, a cheap board, and people who does that usually find two main modules on the thing, is the XR2206 or the ICL8038. These two are the most popular signal generators on AliExpress, under, of course, $10, although the price increased a little bit since I bought it. What you're seeing right now on your screen is the price in Brazilian real, of course. I live in Brazil, I'm Brazilian. And in this video, I'm gonna show you what I received from both products, Then you're gonna assemble, solder everything, and test in the oscilloscope the performance of both signal generators to see, from the cheap ones, what is the best one. So if that interests you, stick around and let's get started. So if you work with electronics, first step with a device is to look its datasheet. So here we are with the datasheet of the XR2206. You can do AM/FM, which is really cool. You can do sweep, but remember, we're not talking about the device, we're talking about modular. More specifically, do-it-yourself kits. So we're not going to look at every single spec of these devices. The most important thing, as you saw in the title, this is a video about analog signal generators. And as you can see, you have a VCO. As if you watched my synthesizer videos, this is a voltage controlled oscillator. Then you have current switches, of course, to bias, and then a a really mysterious block that does the whole magic. This datasheet is not into much detail, but anyway, this is an analog signal generator. Datasheet even comes with a basic test circuit, but we don't need that. We already have a printed board. And here, of course, in the end, just to kill your curiosity, you have an equivalent schematic diagram. Really complex, but if you work with synthesizers and amplifiers, you can see a lot of differential pairs in here. So this is a cue of how this works. So let's jump to the other datasheet. And here you have the ACL, and again, two comparators and a flip-flop, to use to generate, a square wave. These two different, probably because you should be able to work with the duty cycle. But I don't know yet, we're gonna discover. But you have two current sources going to a capacitor, so it gets really linear here. And then the comparator with two flip-flop. And then the buffer from the triangular wave, you go to a sine converter. This is how I actually would develop a signal generator, This is very on the topic of mixed signals, and I love it, You mix digital with comparators and amplifiers, you can make some really cool stuff. And the test circuit could not be simpler. And here's the curious thing. We don't have a equivalent schematic, we have the detailed schematic. Cool stuff. And here you can see how, you see, I told you guys. Duty cycle is changeable and it distorts the sine and the triangular, of course. This is a very versatile device. Let's jump to the, final products, soldering, assembling, and testing, shall we? Hey, how are you doing? So, welcome to my mouse pads, and here we have both kits, Yeah, focus it. This is the XR and this is the ICL. Let's open the XR first because I have a feeling this is, the simplest one. I think I'm actually gonna zoom in, this is really small. So this is the entirety of the kit, so let's throw the plastic away. We have screws and nuts here, acrylic and the PCB. Manual, you're gonna need this for soldering. And all of the small parts, electronics, knobs, sockets, and everything. Basically the same thing for the ICL kits, you know, we have more components, screws and nuts, PCB and acrylic, and I'm really thinking if I should remove the protection of the acrylic. It looks really cool in this, you know, light brown. And the circuit diagram. So I'm gonna solder both here, and this is gonna take a while, so I'm gonna ramp things up, and then after solder and assemble, we're going for the testing. Okay, so this is the manual for the XR2206, and honestly looks really great. You have all the reference definitions here, and you can double check in the board view. And then you have a manual for the assemble thing, so really great. Let's get working. So my first tip to you guys, it will be solder everything that is electromechanical, passive or connector first. Sorry, nothing passive yet, sorry. Everything that is not rated, you know. You have your connectors, the pots are really clear and the indication is written in the back of the pot in here, so you can read the values. This is a connector, of course, connects outside, and a jack. So first of all, do it the easy way, you know. You don't need to be reading and go crazy on the documentation. Come on, focus. Hey, there you go. So yeah, solder the easy part, then go for the data sheet, you know, the schematic, and do the rest. Let's keep on going. So there you have it. The XR2206 board is, if my focus will cooperate, completely soldered. Come on, focus. My god. There you go. Good boy. Yeah. XR2206 already soldered, looking really good. Let's assemble it. So the thing is, I like this, you know, almost wood color, you know, wood-like tone of the protector that comes with the acrylic, so I'm gonna leave this on. And the focus today is not happy. Let me just help him a little bit. Oh, apparently worked. There you go, autofocus is fixed. Let's leave the protection and assemble it. So, first challenge of the XR module. If you solder like me, you know, you cut, you crimp all the... So if you're just like me and you leave a little bit of the, you know, the leads of the components in here, they create a little bit of space, you know? And that space results in a board that is just too tall, you know, for the screws that come with. So I'm gonna use a little bit of hot glue. Give me just a second. So now everything is, you know, hot glued on, and I left the screws for, you know, aesthetics. Let's assemble the rest. And these screws, they are, you know, the ones that you don't need a nut on the bag. All you gotta do, this is really clever actually, just pop them in and they grab the material. That's it. That's how the final module looks, and I like the wood tone of this protection that comes with the acrylic. Really nice. Well, before testing this one, let's put the final parts, shall we? So knobs and jumpers in place. There you go. Knobs and jumper in place. I'm not gonna review this one yet. I'm gonna assemble the other one, and then we can go for analysis of the, you know, the whole do-it-yourself kits and the electronic performance. So, what a hell of an inauguration for my, everything here in the lab. This is the first project I do it in, honestly, almost a year. Let's jump right to the ICL module. Once again, I think I'll keep the protection. Looks so cool. Okay, this one has a lot more going on. I like how the manual just have stuff written over it for no good reason, and I cannot read it because this is, ninja writing for me, and I don't speak ninja, so try to read through, the bill of materials here and finish this one off. So this is the ICL board, all soldered up. Unfortunately, it suffers from the same problem that if you, leave the pads a little bit, it'll offset, the acrylic. So I'm gonna hot glue the screws and finish everything up. So, we are back at the lab here, and for some reason I lost the footage of me talking about the finished second module, but no worries, I'm gonna show you here. And now let's go for testing, this is the important part, and see if the generators actually, function properly. And right from the start, I'm starting here with 2 channels, these 2 modules have the square output and the sinusoidal or triangle in another output. So you have 3 connectors. Let me show you the layouts. There you go. Focus is working really nice today. So you have ground, square, and sinusoidal or triangular, and then you have to select which you want. And by the way, the one thing I don't like about these do-it-yourself kits, I have to use, but luckily I had at my home a jack with 12 volts. And let me just talk a little bit about that. So the manual of both parts, the XR and the ICL, they have different voltage specifications. So the XR, let me just check here. If you guys remember, this is, the manual for this board. And here it states the jack center positive, barrel negative is meant to be used with 9 to 12 volts power supply. More than 12, the output waveform is unstable. I don't know what that's supposed to mean. The datasheet says this IC can go way further than that, but anyway. Problem is, the ICL module, everything here is copy and paste, it's really funny. But this one says the supply voltage should be from 12 to 15 volts. More than 15 may damage the instrument. I don't even know what that's supposed to mean. But anyway, let's trust, dodgy Chinese documentation and go for the experiment. So I had, luckily, a 12 volt, the minimum for one and maximum for another, with the right jack. So it's connected in there, and now we are in the lowest frequency possible. What we already see from this is kind of funny, because amplitude here increases counterclockwise. I don't know why would you do that. So let's just put this to the maximum, which is my left. But course frequency increase to the right. It's clockwise. Why would you do it like that? I don't know. Problem is, with the lowest frequency possible, which by the way, let me show you here, the ranges are, come on, focus. 1 to 10, 10 to 100, 100 to 3K, 3K to 65K, and a whopping 65K to 1 megahertz. So yeah, it jumps really quickly. We are in the lowest setting, and you see the triangular saturates. This is not ideal. Funny thing is, when you plug the scene modes, let me just refresh the screen. Sinusoidal is not that bad. Let me just lower the amplitude a little bit more. It's not like a perfect sinusoid, but it doesn't look half bad, for this weird frequency. So I'm gonna keep the triangular to see if saturation occurs in other frequencies, So let's jump to 10 to 100 hertz. Oh yeah, by the way, when you open it, it just jumps to whatever it wants. Okay, I'm gonna shorten here, and yeah, this is saturation. So let me lower. There you go. For some reason, it lets you, use a bigger waveform that the output stage can provide current or voltage. Why would design something like that? I don't know. But here are. This is really good looking frequency generator. So far this is looking promising. As you can see, you have a generator that provides a really good signal. I don't know why there's a rather large offset here in my voltage. You can see the ground is right here for channel 1 and 2, and if I put them in same volts per division, you can see we're using everything we can for the square wave, but for some reason, turn everything off is stupid. For some reason we are not using everything, for both of them. But anyway, we're gonna use the whole screen here. As we already discovered, these guys don't go full range. There you go. 2 volts per division. We have a significant offset and this response. And of course, if you can increase the voltage, they keep the amplitude. But if I try to increase the amplitude of the triangular wave, it saturates really bad. So this is a signal gen that should not be used without a good oscilloscope, Do not trust, amp, course and frequency like it's gonna work blindly. You need to control this, But let's test the sinusoid wave. And that sign is looking actually really decent. So what I'm gonna do now is just test at higher frequencies and see if this small signal gen actually does what it promises. So this is a 100 Hertz to 3 kilohertz range. We're doing right now 500 almost, and amplitude dropped a little bit, but you can adjust that. So you keep, we have almost, I'm saying almost 6 volts peak to peak here for the sinusoids, and the square is doing a little bit better. 1, 2, 3, 4, 5, 6, 7. Less than 14 volts. It's doing the 12 volts for the square, but the sinusoid and triangle never use that full range. So let's just keep increasing. Now we're going for the range 3K to 65 kilohertz. I'm gonna tell you, this is a good function generator if you want to use for audio. There's a lot of ranges in here for the lower part, and doing well, almost saturating. It's looking great so far. Let's try the final one, which goes from 65,000 to 1 million hertz. And oh, there you go. So the square wave now it's losing a little bit of response, from the edges, but still really clean as you can see. We are doing 100 kilohertz right now. The sinusoid is a little bit skewed. I don't know if you can see that, but a little bit. It's just a little bit. But let's crank this to maximum. And we killed it. So for a good square wave, 300k and it's doing really fine. This is really acceptable. Oh, we're doing maximum amplitude right now, and you're not saturating anymore. So we just have to correct by, by an oscilloscope, the actual amplitude here is not. There's no feedback control. It's not stable over all frequencies. You saw why they got you a amp node here. But the problem is, let me just go the course all we can. So we use refine to increase. 300, looking okay, looking acceptable. 500, okay, not the best. Yeah, it does 1.2 megahertz, but I mean, let's just go back to 1 megahertz. Kind of tricky, but yeah, 1 megahertz, at least, with my probes and my setup here, not looking great. But still, dirty cycle, I believe the dirty cycle here is also off, and you don't have the same rise and fall time here, so this is not the greatest, but still we are reaching 650 kilohertz and it's working. So not gonna lie, I'm really impressed for this kit. This kit was the cheapest one and doing really great, analog and all. So yeah, this was the XR2206 kit, and let's test the other one. Actually, I just forgot to mention, so this is the triangle wave, and the triangle loses a lot of harmonics and ends up being, a really not that great looking sinusoidal wave. So yeah, the triangle over, I would say, 100 kilohertz, just, yeah, but still not that bad though. So as I told you, I promised to show you the finished ICL8038 kit, and here it is. A little bit bigger, more configurations, and some trim pots in the top. I'm gonna test. Looks nice, and the division, the operating frequencies look, they look better because they're more evenly spaced. But the rest is just the same, triangular and sine, square and grounds, and a jack. So now we have the ICL kit here set up, and I'm gonna tell you, this was not a great start because, as you can see, if you trim frequency, let me show you, too low, it just kills the oscillation, which is not great, and it's really finicky between, super low frequency, which is super low frequency, and if I touch the knob, no frequency. This is 0 hertz. So not great. No, because now this is already 3 hertz, What if I want 1 or half? This is really touchy, Really touchy. And another problem with the ICL module, which is more expensive, by the way. Let me just put the... Yeah, you can control the dirty cycle. Dirty cycle is operating normally, as far as I know. Amplitudes. Look what happened with I decrease the amplitudes. Yeah, both levels go down. This is not an offset because the offset is cranked really, really high. Look, I'm putting more and more. Now it's saturating, but it moved upwards. This is not a great offset and amplitude setup here. And if I move the upset a little bit, yeah, okay, great, and it starts saturating. But if you put them in the middle, what is that supposed to mean? Well, would you look at that? The module generates negative voltages, which, it's a cool feature, but at the same time, I don't think it's, should be specified, The other module a maker can get to use with Arduinos and ESP32s and start learning electronics. This guy here without an oscilloscope, kind of hard to set up because, as I told you, you know, the frequency knob is not in the maximum. You see here? Let me just show you without shadows. There's a dead band here, and then it goes right up to really high frequency. So I don't like the way frequency works, and you know, the amplitude just goes from minus to positive voltage, you know. And I didn't know it had the specification. In the manual there's no, you know, no information about that. So this is a great feature, but at the same time you should have an oscilloscope with this one because it can actually damage your equipment, your parts. So let me center both sides here, and there you go. This is the full idea. Amplitudes, you can see the limits of this guy, and it's a really good range actually. You know, really good range. You have it's not using, you know, all the 12 volts we give it, but at the same time the XR module also did not use all the 12 volts. But this guy has a negative part that I really need to lower the amplitude a little bit to get full use. And I'm using the rolling time axis mainly because the frequency here is really low. Like, you can make, you know, this is less than a hertz here, 1 hertz. So what are the two pots in the top used for? So here it says in the manual something kind of cryptic. The square terminal is connected to the oscilloscope. Adjust dirty button to make the rectangular wave duty 50%. So I guess it's kind of doing that, you know. Let me just change the roll model to Y versus time. I mean, this looks good to me. And then switch J1 jumper to sin. So let's change triangular to sine. Yeah, this sign looks terrible. Now adjust the blue and white potentiometer R2 and R3 to the sine wave crest through distortion to a minimum. I don't know what that's supposed to mean, but hey, let's give it a try. Oh, I get it. I don't quite get what are the functions I'm mixing up here, but the sinusoid kind of looks okay, so I'm gonna leave it like that and not adjust anymore. And here it says debugging is completed. R2, R3 after, no need to tune. That's English. Congrats to whoever wrote this. You did your best. So that done, let's switch back to triangular because it's full of harmonics. And now let's start cracking up the frequency, see what this guy can do. So as you can see, you know, it's in 5 to 50, way too low. Let's go 50 to 500. And things are looking really fine, honestly. Oh yeah, now the update rate is pleasant to the eye. Looks good. And of course we can go really crazy with it. Starting to get a little bit of a spike, but if not for that, let me just see what the spike has to do with this. Absolutely nothing. So yeah, let's test the sinusoids. Kind of crappy, kind of okay. I don't know. The other one was better, honestly. Let's go for 500 to 20k. So for the audio guys that are not testing, oh yeah, okay. So this is the maximum frequency we can make within the 500 to 20k hertz. This is 25 kilohertz, and the spikes on the triangular wave are terrible, and the square wave is not great, honestly. So What happens when you turn to, you know, 20K to 400K? Oh boy, that's not good. The triangular wave lost a lot of harmonics and got some new, to be honest. And yeah, the square wave is beyond saving, honestly. No, it's cool that you have a dirty cycle controller here and an offset controller here. This board here is good for you if you want to work with audio, you know, but the XR module just is light years ahead of this one. Way better. This guy loses its capability of generating anything reliable way before the other one. Like that rise time for the square wave is terrible. Jesus. Even the sine wave doesn't look that great. Let's see if adjusting this pause do anything. It does crap. Yeah, I'm really let down by this module, to be honest. Not great. But if you wanna use for audio, the audio part is actually not that bad. It's until 20K. So yeah. What's up? Just wanted to say, you know, thanks for watching. I hope you got some ideas, you know, about these modules. My conclusion to this video is this guy, the XR2206, is much better at generating signals with, you know, a lot of integrity up to the 1 megahertz. It you know, promises as the selling point. You know, it goes really high. It actually goes really high and quite decently. So XR2206. Amazing performance. Regarding the ICL8038, I'm actually quite let down, you know, it's a lot more expensive, bigger, more complex, and I don't know, has a little bit more of freedom to do some stuff, but at the same time, I don't know, man, we're doing low frequency here and you already can see the spikes on the waves and sinusoid doesn't look as good, even adjusting stuff. So yeah, if you're a beginner, get the XR. It's super cheap. I mean, what, $2-3 with the, you know, the transport fee. So that's a gift, you know. That's super great. And if you're a little bit more experienced with electronics and have an oscilloscope at home, I mean, both kind of required an oscilloscope, but this guy definitely requires an oscilloscope way more than the other one. And honestly, only get the ICL module if you work with audio, you have an oscilloscope and you're experienced about what you're doing, you know? This 30 cycles just pissing me off. There you go. So yeah, this was the quick review, you know, of both of the cheapest function signal generators available on the market right now as do-it-yourself kits. I really don't like the way the outputs are, you know, have to screw things in there and, you know, a lot of moving parts and a lot of, you know, degradation over time. I don't quite like that. So if you get, you know, get Dupont wires, or, you know, these cables are using, you know, these cables here for they're marketed as protoboard cables. I don't know if you can have protoboard wires and all, but these guys are great, and you put them there and never take back, and then you plug stuff you use it, so the screws don't get overused over time, the plastic and all that. And you need a standard jack with 12 volts, or 9 to 12 for the XR and 12 to 15 to the ICL, if you want to believe the manuals. That's it. This guy for the beginner and general use. This guy only if you have experience, and if you work with audio, actually has some, you know, the dirty cycle for square, dirty cycle for triangular maybe can be useful to you, but the distortion and you know it dies really quickly. I don't know, it's probably on the board more than on the IC, but anyway, I just wanted to thank you for watching my video. Hope you learned something. This is the first video on how to build your lab, you know. I want to help people build the labs and learn electronics and embedded systems, you know, pass on what I learned so far. So thanks for watching my video. Thanks for coming for my underground archives, and see you in the next video. Bye bye.